Right, again, we're going to look at the numbers in the question first. So as iron from the blast furnace contains carbon in the steelmaking process, oxygen is blown through molten impure iron. At stages during this process, samples of iron are taken and analysed to determine the remaining carbon content. One method of analysis involves a redox titration. So if you ever see that it's a redox titration, immediately say to yourself, E Mr. T, because that's the process you're going to have to go to answer the question. We'll go back to what that means in a second. Then we're going to look at the numbers. So it says at one stage, a 1.27 gram sample of impure iron. It's important you see it's impure, because the fact it's impure means that you are unable to work out the moles from that 1.27 grams. You don't know what else is in there. It's not just iron. And it reacted with an excess of dilute sulfuric acid. All the iron in the sample was converted into iron 2 sulfate, and the hydrogen was evolved or given off. The solution was formed. The solution formed was made up to 250 centimeters cubed. So that's usually what happens in a redox titration, that you've got a bigger volume of substance that you then take 25 centimeters cubed from. And that sample of solution reacted completely with exactly 19.6 centimeters cubed of 0.002 moles per m cubed solution of potassium manganate. Okay, so first off it says write an equation for the reaction between iron and dilute sulfuric acid. Now that actually isn't part of this calculation process, but we may as well do that. Now the fact is iron 2 sulfate should tell you that it's this that's being made, because the sulfate ion is 2 minus and it's iron 2 plus in the compound, so that's the ratio of the iron and the sulfate ions you need to use. It also says you're making hydrogen and you're reacting iron with sulfuric acid. So that's already balanced. Now, the next part asks you to write an equation of the reaction of iron 2 ions with manganate ion. So this is the E bit of our process, which isn't always separate to the calculation bit. So the E part means to write an equation. So you've got to write a redox equation so that you can use the ratio in that redox equation in the next part of the answer, or next part of the working. So you've got iron 2 ions, and they'll be oxidised to iron 3. And you've got manganate ions, which is MnO4 minus, being reduced to Mn2 plus. Now that manganate to Mn2 plus is a process you need to learn. They won't give you that. So then we can balance. So we're going to balance the top one with electrons, and I'm going to balance the second one with first waters to balance the oxygens, then with some hydrogen ions to balance the hydrogens, and then with electrons. And you need 5 electrons on this side to balance the charges. Now this asks you for an equation for the reaction between iron 2 ions and manganate ions, so you do need to combine these to get this mark. If the whole question, if the equation bit was part of the bigger question, like below, then you wouldn't necessarily have to combine them, because all you want is the ratio from it. But you do need to multiply the top one by 5, so the electrons cancel, and then add them together. So you're going to have 5 Fe2 plus 8 H plus MnO4 minus makes Mn2 plus 4H2O plus 5 Fe3 plus. So now going into our calculation part of this question. So the next part is M, which stands for moles. So look at what we can work out number of moles of. We've got a concentration and volume there of the potassium manganate. So moles of the potassium manganate, or the manganate ions, remember the potassium is a spectator ion in this, equals 19.6 times 0.022 over 1,000, and that gives you 4.312 times 10 to the minus 4. Then we can use the ratio, which is what the R stands for in E Mr. T. So the ratio we've got here is 5 to 1. So therefore the moles of the Fe2 plus that reacted in that titration will equal 4.312 times 10 to the minus 4 times by 5, and that will give you 2.156 times 10 to the minus 3. Then, as we normally have, we've got a multiplication there. We only took 25 centimeters cubed of the whole sample, so we've got to multiply this by 10 to work out how many moles of Fe2 plus there were in the 250 centimetre cube sample instead, that equals 2.156 times 10 to the minus 3 times by 10, which equals 2.156 times 10 to the minus 2. And then we can work out the moles of iron 2 plus that gives us. So the mass of iron 2 plus, the mass of Fe2 plus equals the moles, 2.156 times 10 to the minus 2, times by the MR of iron, which is 55.8, and that gives you 1.203 grams. Now, I should have said before that stage, what I would do in an exam is I'd go back to the question and look at what it's asking you, because you know it's a redox titration. So these three steps, these first three steps here, where you're working out moles, then using the ratio, and then doing the multiplication by 10, they should always happen. But there's always going to be a bit where it's going to be different in terms of what you're trying to work out. So it's asking you work out the percentage by mass. Here it is, percentage by mass of the carbon in the 1.2 gram sample. 1.27 gram sample of the impure iron. So that's why I knew I had to work out the mass of the iron 2 plus, because it tells you that carbon is the only the only impurity. So I can now work out the mass of carbon in that sample, because that's going to be 1.27 take away 1.203, which gives you 0.067 grams, and then to work out the percentage impurity, I then do 0.067 over the full mass times by 100, and that gives you 5.28%.